Guys, we continue to go through probability, and today things are about to get crazy. So let's pay attention. So I had drew a little picture here. I'm assuming you can see it on the screen, and those are three cookies, and one of them's a chocolate chip cookie. Now I'm not a big, huge fan of chocolate chip cookies unless they're homemade and right out of the oven. I'm all about it. I'm more of an oatmeal cookie kind of girl or a sugar cookie kind of girl. But let's just say there's these three cookies. One's chocolate chip, and you want that chocolate chip. Now, if I put these three cookies in a bag, what's the chance if you just reach your hand in the bag and you don't get to touch, you just have to kind of grab the first one that your hand wraps around? What's the chance that you're going to get that chocolate chip cookie? Well, the chance that you'll get that cookie, since there's three total cookies and one's a chocolate chip, the chances of you getting that chocolate chip cookie is 1 out of 3. So you reach on into that bag and oh no, you got the sugar cookie. Sugar cookie, you got that sugar cookie. And now I'm like, okay, now I get to reach in and pick out a cookie. Now, did you change the chances for me to get that chocolate chip cookie? Are my chances of getting that chocolate chip cookie the same as yours? Or are they better? So take a look again. How many cookies are left in that bag? That's right, there's 2 cookies left in that bag. How many of them are chocolate chip? One. So the chance that when I reach in and get that chocolate chip cookie, that I'm going to get that chocolate chip cookie are now 1 out of 2. So I'm going to go ahead and reach on in. And guess what? I got the chocolate chip cookie. But you know what? I'm going to give it to you. So we have a situation right here that's different from yesterday. Yesterday, we talked about independent events. Independent means the one event, like flipping a coin, doesn't affect the next event, like flipping a coin a second time. But sometimes the event does affect the other event. And we call this dependent events. And again, I'm not quite sure how to help you understand or remember the actual word, but if you think of today, dependent, how a baby depends on their mother, or independent, like yesterday, like Independence Day, which is America's day to declare their freedom. So I don't know. Maybe that'll help you remember. But today we're going to be doing dependent events. And so for their one to depend on the other, there must be more than one event. So we're not talking about a simple event. There's always going to be a compound event, one that affects the other. Now, there are some words to look at, and in this on your notes today, they're highlighted in bold print every time. And so you got to pay attention to them. So yesterday we had a situation where we were pulling colored tiles out of a bag, and there were 16 tiles in the bag, and we pulled out a tile. And then do you remember what we did with that tile? We put the tile back into the bag. So when we pulled up the second time, there were still 16 tiles in the bag. Well, today it's going to be different. Today we're going to do without replacement. So when we take something away, we're not going to give it back. So let's look at our situation that we have here. We have another paper bag and it has 2 red, 5 blue, 1 yellow, 4 green. And it says, what is the probability of drawing out a red tile, not replacing it, then pulling out a yellow tile? So like every other thing we've done the past few days with probability, the first thing you need to figure out is the total possible outcomes. And so we've got 2 plus 5 plus 1 plus 4 is 5, 6, 7, 8, 9, 10, 11, 12. There's a total number to start. And if theoretically you get the red tile and don't put it back, how many tiles would be in the bag now? 11, of course. So watch how this changes the problem. So picking a red tile. There were 2 red tiles. I'm going to go ahead and put red and the total. There were 2 red tiles over 12. If I simplify this, I get 1 over 6. Okay? So that's the chance of me getting a red tile. Now, the next one is yellow tile out of the total. I've got how many yellow? 1 yellow. And the total number in the bag is no longer 12, it's 11. So I have 1 out of 11. And I can't simplify that. That's as good as it gets. Now, to figure out the probability of grabbing both of those tiles, I'm going to multiply both fractions. Multiply. So I have 1 times 1 is 1. 6 times 11 is 66. So the probability of this happening is 1 out of 66. So not a very good probability. Let's look at another one. What is the probability of drawing a green tile, not replacing it, then drawing another green tile? Now this is different. This is going to affect the numerator and the denominator of the fraction. So let me show you what I mean. So the total number of tiles to start, we're going back to pretend all the red and the yellow are back in the bag. Okay, so the total number are 12. If you get the green tile and don't put it back, how many will be in the bag? Well, 11. How many, if you reach in and get a green tile, how many green tiles are going to be left? Well, we started out with 4 green tiles. We took 1 out. So now there's 3 green tiles left. So let's see how this works mathematically. So green tile, we started out with 4. So it's green over the total, which was 4 over 12. Again, don't know why that disappears, but there we go. Okay, I can simplify this to 1 over 3. Okay, remember now I took a green one out. So now there's only 3 green ones in the bag, and there's only a total of 11. Now I can't simplify that fraction, so I'm done with that. Now, what is the probability of me reaching in and getting a green one and then reaching in and getting another green one? 1 times 3 is 3. 3 times 11 is 33. I can simplify that to 1 over 11. So the chance of that happening is 1 over 11. Let's go to the final situation, which, by the way, example 2 is about as hard as this gets. Okay, what would be the probability of picking a red tile, not putting it back, then picking out a blue tile, not replacing it, and finally picking out a yellow tile? So now we have 3 events. So let's do each event. Now remember, we started out with 12 in the bag. So red over the total would be, how many red? I have to go back up here and look because I don't remember. 2 red. 2 red. Okay, I can simplify that to 1 over 6. Okay, yellow. Yellow over the total. The total is now 11. And again, I got to check how many yellow. I can't remember. There was 1 yellow. I'm going to put 1 right there. I can't simplify it, so that one's done. Now, I'm going to pick a blue. Blue out of the total. Well, remember, I had 12. I pulled out a red. I have 11. I pulled out a yellow. Now I have a total of 10. And how many of them are blue? I don't remember. Let me go back up here and see. 5 are blue. Now I can simplify this, so I'm going to 1 over 2. Okay, so what's the probability of pulling out a red one, then pulling out a yellow one, then pulling out a blue one? I'm going to multiply each one of these. 1 times 1 times 1 is 1. 6 times 11 times 2 is 132. Are your chances good on this? Would you put money on it that you're going to pick out a red, then a yellow, then a blue? Because your chances aren't very good that you're going to be successful. Your chances are 1 out of 132. Not too great. Okay. If you need help with this, please don't hesitate to ask or watch this video over. I'll see you later. Bye-bye.